Okay, welcome everybody. I'd like to start today by acknowledging that the University of Melbourne sits on the lands of the Wurundjeri people who have been custodians of this land for thousands of years, and acknowledge and pay our respects to their elders past and present. It's my great pleasure today to be able to introduce Foong King Yew. Foong's actually a Bachelor of the Department of Electrical and Electronic Engineering at the University of Melbourne from the 1990s, and went on to do an MBA at NUS. More recently, he was the VP and Chief of Research at Gartner, focusing on telecoms, IoT, and other disruptive technologies. Currently, he's working as an independent communications industry consultant based in Singapore, and with over 26 years in industry, I think is exceptionally placed to be able to provide insight into the transformations that 5G and beyond really offer. So I'm really looking forward to Foong's talk today, and I'll hand over to you now, Foong.
Thank you very much, Chris, and a very good afternoon, good evening, and good morning to all the attendees, wherever you are around the globe. And it's indeed a great pleasure, for me to be able to present here for WILAB with regards to, how I see the technology future enabled by 5G cellular technologies. So in this seminar, I would like to discuss and share with all of you my vision of how, the future would evolve, what are the key drivers, what are the key challenges that will impact the changes that are coming right through to 2030, right? And I will present in such a way that it will be shorn of all the typical bells and whistles that you tend to hear from the market trying to talk up the technology and the future. So I will present in a very objective manner and laying it out in a very stark and bare fashion as to what I see the future would look like. So we have seen, right, let's go back 2 or 3 years ago, 2018, 2017, 2019 time frame, where the 3GPP promised us this wonderful technology called 5G that can do many wonderful, incredible things. Unfortunately, that plan has been derailed by COVID, right? And in 2020, the 5G Release 16 standard was finally made available in the market, and it brought along capabilities in unlicensed spectrum band, support for private networks, industrial IoT. And now moving forward, we will be getting Release 17 in 2022 and Release 18 perhaps towards the end of 2023 or early 2024, where Release 18 will have support for position services and timing services as well. Now the key thing here is that whatever that has been promised is not going to come in one nice bundled package. It's going to come in phases, step by step, and up to 2030 we may see Release 19, Release 20 even. So I see the market progressing in an evolutionary fashion as opposed to a revolutionary one, right? Now, in terms of 5G adoption, it's important to understand this key driver called interdependency. Right? Now imagine that we are all seated in our favorite sports car, right? Be it a Ferrari or a Lamborghini, and there's this stretch of endless highway in front of us. But unfortunately, at every step, 500 meters or so, there are traffic lights there. So the only way that you can drive as fast as possible down that highway is for all these traffic lights to be green. Now, the analogy here is that the car is your 5G technology. And each of these traffic lights represent the key market factors that's going to impede on the speed of adoption, right? Now, I see the maturity or the sophistication of each of these factors will differ from markets to markets. Some markets will be more advanced than others and will move down the 5G superhighway faster than the rest. Now, for example, regulators. Now, this is very important. In some markets, the governments are heavily behind this 5G technology, driving the adoption. Countries like China, South Korea, for example. Some markets like in the United States, they have released the CBRS spectrum, and also some countries in Europe as well, to enable the implementation of private networks amongst enterprises. Consumers and enterprises are also important in a sense because of their readiness or propensity to consume 5G services. Right, and here's where the service packaging, the price, and the ability to perceive 5G value is going to be key as to whether 5G adoption in a mass market really takes off or it takes off slowly. Devices, there will have to be a lot of choices, proliferation of many form factors, and of course affordability as well. And so is the partner ecosystem. It's very important to have a vibrant applications developer ecosystem, device manufacturers, for example, to really drive the whole entire 5G ecosystem forward. And then there's this whole set of adjacent technologies. And some of them, will still take 2 to 5 years for them to reach maturity or mass market adoption. So in this sense, the next 2 to 5 years will be a very critical one for 5G. Now, if all the stars are aligned, then we're going to see 5G technology adoption accelerate very quickly and percolate through the different segments of the market, consumers and enterprises alike. And now, because of this, right, many of the 5G applications that we have today, it's still pretty much at the proof of concept stage, right? We have many of the use cases or the press releases that we see in the market today. The majority of them are still at the proof of concept stage, where the vendors are still trying to prove the viability of the technology features and capabilities. But I believe it will move very quickly towards the proof of value stage, where the 5G capabilities will and can demonstrate the value in terms of new value creation or cost savings the 5G adopters. Now, many of the use cases that we have today, right, a lot of them can be supported by 4G. So in terms of 5G specific use cases, a lot of the service providers are still looking for that killer application. Many service providers have established innovation centers to attract developers and innovators to see what is possible with this technology. Now, from my perspective, I see 5G as an enabler, right? It is not a magic bullet that can solve every single problem. To me, it's about 5G as an end-to-end solution, taking advantage of the 5G features, enhanced mobile broadband, massive IoT, ultra-reliable, low-latency connections, in conjunction with the adjacent technologies that I alluded to in the previous slide, So technologies like cloud computing, augmented reality, virtual reality, AI, machine learning, analytics, and IoT, they have to all come together as a solution to be introduced into the market. Now, if it's only about 5G as a standalone service or solution, it's going to be very difficult for 5G to gain traction in the market. And it's all about the value what 5G can deliver for the consumers and enterprises alike. Now, there are a few key focal points here. In fact, there are 5 that I wanted to share with the attendees here and hope to highlight, what makes 5G so different this time around compared to the previous technology iterations. 5G today, right, basically coincides with a very key change in the enterprise market, right? In the sense that enterprises today are deep into digital transformation due to competitive challenges and the need to grow revenues and to be more efficient. So they are looking at the number of technologies, and obviously 5G is included, along with hybrid cloud, AI, ML, analytics, automation, and digital twins. Right now, how fast this car is going to go down that superhighway, right, depends on 3 key factors. It's about the ability of the enterprises to transform their processes. Are they able to adopt agile IT, DevOps? Now, technology is the easy part, right? The ability or the resources to invest in new technology. But one of the key stumbling blocks is the people factor. Because the changes brought about by technology and processes is going to change the way people work. It's going to make a lot of jobs being displaced, right? And there will be new ways of working alongside machines, working alongside analytical tools. In fact, maybe even being advised by a machine or a robot, or being given a set of recommendations by the engine as to what to do when certain events or scenarios emerge. So there's going to be a lot of uncertainties and perhaps even a lot of fear in the organizations as to job security and as to the future skills and talents that will be required in a 5G-enabled future. Now, depending on how enterprises surmount these 3 challenges, it will affect the speed of 5G adoption through the enterprise market. Now, closely related to this, enterprises and 5G, and also I think it differentiates 5G from the earlier technologies, is the area of private networks and network slicing, right? Now, this trend will be very apparent in North America and also in parts of Europe and parts of Asia, where specific spectrum has been made available to enterprises so that they can pursue their business transformation efforts using 5G. However, there are still a lot of uncertainties here in terms of business models, whether, do you build your own private networks or do you go for service providers, network slicing, service? And whether, a particular enterprise would wish to invest in their own wireless engineers or cellular network engineers to build and to manage all these networks by themselves, right? Now, according to Tariq Amin, the CTO of Rakuten, he expects or envisions that private networks, should be as easy to deploy as Wi-Fi networks in order for private networks to take off. So that is his vision, and who knows, it may come about in the years ahead, right? But one scenario that I envision, among many other possible ones, is this. I see the global multinational corporations as the first movers, towards adopting private networks, right? They have the resources, and most of them are also very likely to have the technical skills as well to pursue their own implementations together with their selected systems integrators. The small and medium-sized businesses, those would be the later adopters because they lack the technical skills. They also lack the resources, and they would most likely look towards service providers for a network slicing solution. And large companies, well, there will be a broad spectrum of them, some of them would pursue their own private networks, and some of them may pursue their own a network slicing solution as well. Now, the interesting technical challenge here for network slicing is this, right? And here is perhaps where the university 5G researchers may have an interest, right? How many slices are actually possible before the network performance degrades? Because we all know that having a big single large data pipe, right, it is more efficient compared to many small data pipe that carry the traffic. The single pipe is definitely more efficient compared to the smaller one, right? So how would this impact an actual network slicing environment? How many slices can the service provider optimally provide in the market? Now, I've spoken to some network equipment vendors before, and I have yet to receive a definitive answer to this. So this is something quite interesting to look at, and it may also at the end of the day impact the viability of large scale implementation of network slicing. And now moving forward to the third key point is the intersection between 5G and multi-access edge computing. And here is where, as I mentioned earlier, there's a lot of proof of concepts happening. Not so much proof of value yet, but proof of concept, where a lot of service providers and developers are trying out in conjunction with retailers, car manufacturers, and industrial companies as to how they can best leverage this technology. Now, the key drivers, I think, are pretty obvious in the sense that when there are less hops in the network, right, you'll tend to get more reliability. And with 5G, we should be able to get sub 10 milliseconds performance. And then there is also the network efficiency aspect as well. By processing the data at the edge, right, data need not be sent through the wide area network back to the core network where the processing takes place, and then the results or the action is then sent back through the network again to the end user site, right? So there is obviously a lot of network optimization benefits to be realized here. Now, but is edge computing mature already? Well, some of the adjacent technologies still needs time to develop, right? Particularly autonomous vehicles, right? Level 4, level 5 type of capabilities. AR, VR, I think it still takes maybe another 5 years at least for it to reach a mass market scale of adoption. Cybersecurity will be one key concern as well, because if you have many edge nodes, then your data will be distributed across a very large area as well. And then that means the surface area for cyber criminals to attack has been amplified many times over. And then there is also the business model aspect as well. And here what I mean is, private edge versus public edge. Now, public edge will be one that will be provided by the service provider or telco, right? The edge computing hardware resides at the edge of the telecom network. Whereas in a private edge scenario, the hardware and the computing lies on site at the customer premises. Now, which model or which adoption style would prevail? It's still up for debate. And for me personally, I feel that both models would coexist because there are so many types of demands and requirements out there in the market, and there's no one-size-fits-all solutions that will satisfy everybody. So I expect public and private edge models to coexist in the market. Now, the fourth point here is about 5G and massive IoT, right? There's been a lot of talk in the market by industry participants about how 5G is going to transform IoT. It's the best thing since sliced bread. Now, the reality here is this. There is a wide range of access technologies that can enable IoT solution, right? Not only 5G, but there's LTE-M, narrowband IoT, and then you have the low-powered wide area network technologies like LoRaWAN, Sigfox, and then you have your next generation Wi-Fi, which is Wi-Fi 6. Now, the choice of technology is going to be driven by the specific use case requirements, right? And also by many other factors as well, the availability of spectrum, the price of wireless modules. Now, most IoT projects are really massive and you really need scale, right? And some of these LPWA access technologies, they are able to drive the wireless module prices down to $1 to $2. So the question now here for the market is whether the wireless modules for 5G, can it reach the same price points? And if so, then when can it reach that same price points? So this is some of the key considerations that will drive the technology choice. Now, for me personally, I see 5G will be a good fit for IoT solutions that really require high security requirements, high data throughput, low latency response. That to me will be the sweet spot for 5G technology to be used, right? Narrowband IoT can and will also be supported in 5G as well. But then the frequency spectrum, or the frequency range is different. So again, there is the economics factor and the cost factor coming into play as well, so far as when and how soon and how fast the 5G based IoT solutions can come into the market. But here I do expect that the market will be one where multiple access technologies will coexist, and the service providers who will be pitching the 5G solution will really need to be very careful and astute as to the use cases that they want to target. They need to really play into the strengths of the 5G capabilities. And lastly, the fifth point here is about 5G and sustainability, right? As we all know, the climate is rapidly changing, and one of the key focus areas that will emerge will be the question around how 5G can help improve sustainability, right? And what is the 5G carbon footprint contribution, right? So there will be a lot of focus here on energy consumption and how 5G contributes to a circular economy. So one area here of interest around sustainability and 5G, and also back to the previous slide about massive IoT, will be smart cities, where we are looking at many thousands, if not millions, of connected devices in the near future. So this is going to be a key area, and here is where in terms of the best model, that all segments of societies will need to get involved. It has to include the technology providers, the enterprises, societies, meaning you and I, and also the institutions. And institutions will include governments, ministries, related NGOs, and of course universities such as the University of Melbourne. So here we can see that in this sense, right, to really be successful in smart cities, teamwork is important, right? Coordination is important, and that's where all these four key stakeholders have to come together to ensure that there's innovation, security is taken care of, and the supporting infrastructure is robust and is able to sustain the demands of all these use cases. And I foresee that in the next coming 10 years and maybe even beyond, this will increasingly be a big focus area, because we are talking about solutions such as smart traffic management, smart buildings, smart grids, smart metering, smart waste disposal management, and also smart healthcare as well, which is going to transform the way we live, work, and play. So again, here one of the traffic lights here, right, back to my earlier slide, is the ability of all these four stakeholders. Can they come together and play well together, right? If they can, then the traffic light is green, and we'll see a lot of innovation and a lot of improvements towards the lifestyles in the years ahead. If not, then it will take a while longer. Now, just shifting gears a bit, what can we expect in the market? So let's focus on the consumers first. Now here I took a snapshot from a paper from Docomo Digital, where they cited Omdia's research, and there's really nothing new here, right? In terms of 5G-enabled future for consumers, we expect video to take the lion's share of the use case, music, cloud gaming, mobile games, AR, VR 2%. Again, I think that is to be anticipated from my comments that it'll take another 2 to 5 years for the technology to mature and percolate through the market and achieve mass adoption. Now, the more interesting thing here relates to consumer segment is the media and entertainment segment. Now, in South Korea, some of the service providers like Korea Telecom and SK Telecom, they've started to talk about this concept called the metaverse, right? Which I take to be a combination of 5G plus AR, VR, and XR. XR is extended reality, and then with AI and ML to the mix. Now, many of you will recall, right? Back in 2003, there was this Linden Labs creation called Second Life, where everybody goes online and live a virtual life away from reality. And I think many will also recall Steven Spielberg's 2018 movie, Ready Player One. So I think there's a good chance that we are moving towards this metaverse as well, where we submerge ourselves in an alternate reality to get away from the nitty-gritty challenges of life and to live an alternate life in the virtual world. So there is, to me, a lot of opportunities here, in conjunction with 5G. And apart from that, there's the standard high quality video, mobile gaming, esports as well. So these are the potential. Now the challenges is more from the hardware or the device side, right? For a mobile screen, 5.5-inch or 6-inch mobile screen, do we really need high definition video? Does it really make a huge difference given that small screen? And what about battery performance, right? Can the battery performance catch up with the requirements for computing power? So these are some of the challenges here. Now, from an industry perspective, right? Now, I wanted to highlight some of the key industry verticals that can be transformed by 5G. Now, the industrial sector is by far one of the earliest adopters, I would say, and there's a lot of interest, a lot of opportunities in this segment. Some companies are talking about a factory where their only fixed assets are the floor, the ceiling, and the four walls that define the factory space. The rest of the assets inside are reconfigurable, right? The machines, the workstations, all that, they can be moved around depending on which product lines and product configurations they want to focus on, right? And there is increasing move towards automation, precision manufacturing, and already in Taiwan as well, there are cases where computer vision with 5G, enabled by 5G, is used to inspect semiconductor products, quality assessment, inspections, tracking of inventory and parts, and to enable workforce safety as well, right? And many of these are also driven by governments, like for example, Made in China 2025, for example. And as I mentioned earlier, governments have made available specific ranges of spectrum so that the enterprises themselves can pursue their own private network. So there's been a lot of catalysts, in this area. Of course, as in all cases, not everything is hunky-dory. A lot of manufacturers and a lot of factories, they are still hampered by legacy manufacturing execution systems. A lot of their data are still distributed in many different parts of the factory in silos, and it will still take a lot of work for them to pull together their data management and to upgrade their communications protocols and to change the way that they work. But smart factories, it's really, to me, a very, very promising area where 5G can really be put to use in the vertical industry segment. Now, next would be the transport and logistics, right? Smart ports, for example, the poster child or poster children for this is the port of Hamburg, Rotterdam, Marseille, for example, where some of the use cases like video surveillance, drone operations, remote controlled tugboats, autonomous vehicles have already been tried. So far, right, most of these ports, they start with 4G, right? And I want to be very clear here that 4G cellular technologies can support this smart port implementation, right? So from a 5G perspective, the value would be that better performance, better security, better latency. So now we are starting to see that many of these ports are starting to shift starting to trial 5G and to shift towards this next generation technology. Now, another area is autonomous vehicles, right? Now, this is a longer term scenario, right? Maybe 2025, 2026 and beyond, where we will see multiple modes or modalities of interactions, man to machine or machine to machine, maybe I should say vehicle to vehicle, vehicle to infrastructure interactions, right? It's going to be a very complex undertaking, right? But today, realistically, where we are right now is maybe at the high end of level 2, going to level 3 type of autonomous vehicle capabilities. Now, to move into level 5, that will still take some time. All right, and there's still a lot of issues to be resolved, particularly around safety and liabilities. Let's take, for example, a situation where imagine an autonomous vehicle hits a passerby on the sidewalk. Who is to blame? The car manufacturer, the driver, the software maker, or the computer vision equipment? It's still very unclear who you're going to point the finger to, right? And even recently, we have come across reports about crashes by Tesla. So it's still very challenging for vehicles to really accommodate these wide ranges of environment. So I expect early deployments will be in well-defined situation like campus environments, warehousing, in ports, and also in mining industries. So here, it's a chart where I try to show the interrelationship between 5G and autonomous vehicles, and this is from the 5G Automotive Association. Now, on the left-hand side, you can see that the different levels of safety standards with the different timelines for the markets to take off, right? And then at the first horizontal row at the top there, you can see superimposed on it, the time frame for the releases of the 5G standards. So to reiterate again, things are not going to come in a big bang fashion. It's going to be step by step in an evolutionary form. And some of these safety levels, 4G today can already support them. Some of the higher level safety standards, of course, will require 5G. So overall, I'm actually looking at 2026 and beyond to be realistic, for these autonomous vehicles to really take off in a bigger way than it is today. Now, in terms of other industries, mining is one that has great potential, of course, because of the harshness of the environment, and also because of the remote areas. Private network implementations, will be key here. Agriculture, there are some interesting use cases, but the main drawback here is that most of the agricultural farms or areas, they are rather remote in nature. So does it make economic sense to roll out 5G in a remote area where the population density is low? So this is one of the big challenges facing the agricultural sector so far as 5G is concerned. Healthcare, there are a lot of opportunities, but healthcare is one industry where there's a lot of legacy mindset, bureaucracy, and regulations that will act as a traffic light that will tend to put a brake on the adoption of, or the pace of adoption of 5G. Retail, there are some interesting applications emerging, particularly around video analytics and computer vision to detect retail store theft, for example. But the issue here is, computer vision is not really perfect yet. For example, an uncertain shopper taking the product and then putting it back, picking it up again and putting it back. Some systems may get confused. Some systems may also get confused, failing to detect the differences between an actual shopper versus an employee or staff restocking the shelves. So there are many different types of scenarios which can complicate the use cases. So these four are more, I would say, important and promising segments. One rung below the earlier industry segments that I shared. Now, in terms of 6G, what can we expect? Right. The work on 6G is going to start very soon, and we expect the first commercial 6G to appear around 2030, that time frame. So what can we expect here? I would expect new spectrum, better technology specifications, more automation and AI embedded into the technology, and also network convergence between terrestrial and space or satellite networks. And on a futuristic note, we may see more modalities in the interactions between humans, networks, and machines. And as I've already mentioned earlier, with the Ready Player One movie, immersive extended reality, maybe a mobile hologram is possible, and also perhaps machine as users of 6G. So the work is starting today. Now, I want to, before I end this presentation, I want to just leave you with a bit of a teaser here. Where do we normally search for inspiration? I think one of the best areas to look for inspiration basically is from Hollywood movies, right? When I was a teenager, and I'm sure many of you remember Knight Rider, right? That smart alecky car that can talk, that can drive itself, and voila! Today, we have there was something moving closer and closer towards this shiny black car. And in 1996, the first Mission Impossible movie came out, Tom Cruise. How many of you remember, Tom Cruise coming down from the CIA Langley headquarters, trying to steal some data, and he was wearing these spectacles that looks suspiciously very similar to a Google Glass. And then you have 2002, Tom Cruise in Minority Report, right? When he walks in a retail store and there's this smart AI-enabled chatbot that says, "Welcome back. Your last purchase was this and this and this, and we would like to recommend you, this new product." Now that sounds like an AI-assisted shopping assistant, to me, which is already happening today. And then we have the Iron Man movies. You have Jarvis, the AI-enabled assistant to Iron Man, and again, that is also happening, today. So for me, this is one area where one can get, inspiration and ideas as to what's going to come next. If you have looked at or you have watched the recent Black Panther movie a few years back, you remember the hologram communications, right? Where a hologram of a speaker just appears and then it disappears again when the call terminates. Will that happen, by 2030? Well, maybe. Food for thought. So in closing, I just wanted to, summarize a few key points here, right? 5G, will be evolutionary rather than revolutionary. 5G at the end of the day is just a technology, an enabler, right? To really drive 5G adoption, we have to think more about end-to-end solutions, and that's where the adjacent technologies like edge computing, IoT, AI, and analytics, they really have to come together to form a holistic solution. And of course, lastly, interdependencies. Never forget that. Because if one of those traffic lights are red, you have to slam the brakes on your Ferrari. And then you go from 200 kilometers an hour right down to 0. So all those green lights, all those traffic lights have to be green, right? And lastly, I just wanted to leave you with this quote from, I believe it was from Peter Drucker. The best way to predict the future is for us to create it. So with that, thank you very much for your attention. And Chris, are there any questions from the audience?
Yes, there's a few questions. So there's one. I might switch between the Q&A and the chat, but Gary's asked just for a little bit of clarification in the initial comment that COVID has interrupted 5G deployment and adoption. His thoughts were that it would be an opportunity to promote uptake of new applications and use cases.
Okay, that's easy. Let me respond to that. I think I need to clarify about COVID and 5G. What I said was that COVID has impacted the release timetable for 5G. In fact, I think release 16 was delayed about six to 9 months, if I'm not mistaken, right? And then there is that cascading effect, right? Once release 16 has been delayed, you'll push back release 17 and release 18, right? And with that, the features and the capabilities will come, later rather than sooner. So, that was what I meant. But in terms of 5G and COVID, from an opportunity perspective, yes, that's, it tends to drive opportunities, particularly like work from home and all that, fixed wireless broadband, so on and so forth. That has been one of the areas where growth is possible. And also remote healthcare, telemedicine as well.
Okay, thanks, Foong. I might jump across to the Q&A. So Sampath has asked, do you think there will be large-scale wireless deployments similar to NBN Australia, a common infrastructure where resources are resold to service providers?
Okay. I think it might possibly be unlikely in Australia, but this model, just out of interest, has been adopted in Malaysia, where they have decided to have one single wholesale infrastructure provider, and then this one single wholesale infrastructure provider will sell the bandwidth to the mobile operators. Now, this type of model, I think, tends to be adopted, if there are market failures, right, at the retail end, and they want to facilitate, the proliferation of retail service providers and improve the competition there, right? But I believe in Australia, the licenses have already been issued. I think I need to check on that. But I doubt that Australia would go down that route.
Okay. So with so many 5G rollouts promised in the near term and their reliance on new advanced chips, what impact on timing and scale of rollouts do you see from the semiconductor supply constraints? It's from Jordan.
I'm not really an expert in terms of the supply from the semiconductor side. So I'll probably leave it at that. But I do expect that there will definitely be some impact, particularly if service providers are customers of Huawei. Because right now the high-end 7 nanometers chips, Huawei has been deprived of them, and they are now relying more on their inventory and stockpile, which has accumulated through the recent years. So the big question now is, what happens when the inventory runs out, right? That would be a key concern. So those mobile operators who are using Huawei equipment, I think they would have to think through, the possibilities and the scenarios.
So a question from Ethan, I guess quite topical given most of our audience. What would you see as the most important aspect of 5G that researchers, particularly in EEE, should focus on to accelerate the adoption of 5G? Where are the bottlenecks from a research perspective?
For me, I think it'll be, I think one of them will be around, as I mentioned, right, the area of network slicing and the performance, right? Because, for network slicing to really work, you really need the end-to-end network slicing, not only on the radio access network front. And we know, the one big pipe is definitely more efficient than many small pipes, right? So what is the limit there? That would be the interesting issue there. In terms of commercial aspects, there's a competition right now in terms of who has the lightest hardware equipment or the radio and the antennas, right? Who has the lightest hardware, because that's going to have a huge impact on the supporting masses on the rooftop, right? And you can get that down cheaper than the vendors who can do that would gain a better competitive advantage. Apart from that, right, I think there's always this from a research standpoint, right, the augmentation in terms of performance, enhancement to massive IoT, the positioning and the timing capabilities, and to see how those can map into new use cases, so on and so forth. And also, when you talk about 5G, right, we cannot avoid the topic of automation and AI and ML. And that's where I think, that there's going to be a lot of software work involved as well to make the 5G operations to be as autonomous as possible. So a lot of work is going to go into that area as well. Okay,
thanks, Foong. I might jump across briefly to the chat. So from James, do you think any new industries will arise from the full integration of 5G globally? It's a crystal ball question.
I think, if there's going to be anything that's going to emerge, right? The AR and VR front, I think holds a lot of promise. But I think my last slide here also, answers that question as well. The best way to predict the future of what new industries is to come is, I think, to boldly go forward and create it.
Or to make a film about it, if I refer to your second last slide. So I might ask one more question, just in the interest of time. So Wayne's asked, once 5G is widely deployed, will it replace NBN, or will NBN become the backhaul for 5G/6G? What are your thoughts there, Foong?
Now, I don't believe that 5G will displace or replace NBN. I always believe, in whatever country, right, these two technologies will be complementary. No matter all being said and done, the capacity and the capabilities of wireless, there's no way you can beat light fantastic. photonics. You can't beat that single strand of fiber in terms of carrying capacity, right? And wireless, I don't believe that Shannon's law has been broken yet. It's still very much in force. So what I see is complementarities, right? In rural areas where the economics are against fiber, then wireless would be the way to go, right? So yeah, it's going to be a coexistence of these two technologies.
Okay, well, thank you, Foong. There's still a number of questions that are there, but we might draw the formal proceedings of the webinar to a head, and maybe Foong might be able to stay around a few minutes afterwards if people are still keen to have those questions answered. But on behalf of the audience, I'd like to thank you for a fantastic talk this afternoon. I'd also like to just remind everyone that our next WILAB seminar will be on October 26th at 11 a.m. and Dr. Jen Yates from AT&T Research Lab will be presenting a talk on 5G and AI. And a registration link will be available soon. But with that, thank you, everybody. It was a fantastic talk, Foong. And yes, I'd encourage people that still do have questions to hang around, but we might end the recording now.
All right. Thank you very much for all the questions and all the interest in 5G, and thanks very much to the University of Melbourne for hosting this call.